Hey everybody, I just wanted to go over the logbook for counting how many atoms there are. This is an important skill for balancing chemical equations, right? First, you need to be able to count how many atoms there are on the reactant side and the product side in order to know if they're equal. And then once you have coefficients in the mix, you need to make sure that your count is right so that you can know if you balanced it correctly. So first, I'll just go over the example here in case you needed some help just getting started. So over here, the example is of ammonium sulfide. And we can see here, I wanted to make sure that we had an example with parentheses, so remembering everything that means. So inside the parentheses is NH4, right? And then there's a 2 on the outside. So that means we have 2 NH4 ions. So that's why our count for both the nitrogen and the hydrogen get multiplied by 2, because that parentheses means the 2 applies to everything inside. So here, 2 times the 1 nitrogen is 2 nitrogens, 2 times the 4 hydrogens is now 8, and then the sulfur's on the outside, so there's just one of those. I will go over the rest of the logbook. I just wanted to let you know, please pause this video if you just needed some help getting started, or at any point as I'm explaining, and try to do the problems on your own instead of just watching the entire video all the way through. That way you can see if you needed any help getting started or fixing something, and then you can go back and try them on your own. Okay, so let's look at this first one, MgSO4. In that molecule, magnesium sulfate, there is 1 magnesium, we have 1 sulfur, and then that little 4 just applies to the oxygen. So here we have 4 oxygens. Number 2 is aluminum nitrate. So again, here we just have 1 aluminum, and then this nitrate, right, that NO3 ion, we have 3 of them. So each NO3 has 1 nitrogen, but now we have to multiply that by 3. So my nitrogen count is now 3. And then each one had 3 oxygens, but now I need to multiply that by 3. So my oxygen count is now 9. For number 3, we still have aluminum nitrate, but now we have the difference of having the coefficient in the very front. So this is like if you've already balanced the equation or you're on your way to balancing it, right? Remember that 2 in the front needs to get distributed to everything, because now it's saying instead of having only 1 aluminum nitrate, we now have 2 of those aluminum nitrate molecules. So since we already did the count for just 1 aluminum nitrate, you can just take all your numbers from number 2 and multiply them by 2, since now we have 2 of those full molecules, right? So essentially, this 2 gets multiplied by 1 Al, and then the 2 gets multiplied by the 3 NO3s. So you would need to take into consideration this 3 on the outside as well. So like I said, my easier method is just to think of 1 aluminum nitrate on its own, and now with the 2 in the front, I can just multiply everything by 2. So 1 times 2 is 2, 3 times 2 is 6, and 9 times 2 now, my oxygen count is 18. Right, so you could also see that here, because I had 3 times 3 oxygens is 9, and there's 2 of them, and that makes 18. Okay, for number 4, we have another scenario where there's a coefficient in the front. So I have H3PO4, but now I have 3 total of those H3PO4 molecules. That's the phosphoric acid. So in here, what I'm going to need to count for is hydrogen, phosphorus, and oxygen. So let's take a look at each of those. Each H3PO4 molecule has 3 hydrogens. Now I have 3 of them, so 3 times 3 makes my hydrogen count 9. In each molecule I had 1 phosphorus. Now I have 3 molecules, so that makes it 3. And in each molecule I had 4 oxygens. I have 3 molecules, so 3 times 4 is 12 for my oxygen count. Let's do the last one here. we're going to need to account for iron and account for oxygen for this iron 3 oxide. So again, we have our molecule here, Fe2O3, and from the coefficient in the front, I have 4 of those Fe2O3 molecules. So I'm going to need to multiply 4 times my Fe2 and 4 times my O3. So my iron count, each molecule had 2 irons. I have 4 molecules, so 4 times 2 is 8. And my oxygen, each molecule had 3 oxygens times 4 molecules, so 3 times 4 is 12. Hopefully that helped clear up some things for everybody. Please don't forget to go post in the discussion post to let me know, yeah, I'm good, I get this, or if you still have any questions.